my screen, or you can see my
Yes,
screen? Okay,
yes, we
great.
can.
Awesome. Okay, thank you everyone for attending, and thank you very much for Elena to do the initial poll. So I can definitely tailor my talk afterwards based on the audience we have today. The original material I prepared can go, I would say, quite crazy, I would say, in terms of the technicality and the deep dive into the layer 2 construct. But I'll try to make it more consumable, I would say, so that anyone can understand what layer 2 is about, what optimistic rollup is about, because this presentation is about demystifying the optimistic rollup, which is a term that you have been hearing quite often recently. So my name is Joan. A quick introduction of myself. Oh, this is the agenda. Sorry, here's the agenda. So the first, I'll do a quick introduction. I'll say, hey, what's going on with layer 1? Why do we have layer 2? I'll talk about different rollups. I'll talk about the optimistic rollup and some deep dive. So I'll keep the deep dive a bit shorter. I do have a hands-on session, but based on the audience today, I think I'll probably just run through, kind of give you a general idea what the optimism's implementation of the optimistic rollup looks like. So when in the future, when you're really interested in get to know more about that particular implementation, you have a better kind of direction where you want to go. And I'll briefly talk about Metis and our use cases, how we customize Optimus implementation of OLAR. So a brief introduction of myself. So I started programming is actually from age of 6. My first programming language is BASIC. Back then, BASIC was almost like English. So it's quite easy for me to get basically kind of a first taste of a computer programming. I had no idea what computer programming can do back then, but all I can see is I can actually draw some boxes, which is very nice and very visual, right? So I'm a kind of visual person. I like to see what I make. And then at 10, I know the limitation. I knew the limitation of BASIC. I started to teach myself C and C++. That was more of a low-level programming language where I can actually directly talk to kernel back then and talk to for example, the video memory. I can actually draw pictures by directly write pixels in the frame buffer. That was quite an interesting experience, and I've done quite a number of computer graphic related stuff. Also, one achievement I had in my childhood is I successfully locked my parents out of my computer so that they can never get into, because I create a kind of a boot security locker, so no one can get into my computer unless they know my password. But if I look back now, that was a very weak, I would say, a security measure. But to deal with my parents, I think it's enough. So then I did continue the path of doing being a computer engineer and researching computer science. My thesis is on lifelong machine learning. It was around 10 years ago. So that was a very interesting topic. Now becomes a very hot topic. It was about teaching machines to continuously learn just as humans. So right now, all the machine learning algorithms, they really excel at one particular task. But if you throw them at a different domain, like a complete foreign domain, they have no idea how to handle it. This particular research area is to help the computers, help the algorithms to adapt their previous learning model to deal with the new domain. And that was a very interesting topic. And I wish I could continue research on that topic. But well, life pressures. I still have a family to feed, so I make sure that I need to get a job and get some pay and start to buy a house and have kids. So, but that's still a kind of my kind of side project. I continue research on that. So my specialization after I get into kind of career phase is in a high performance database system. And because of that, I also got a chance to got involved in a Hyperledger project in IBM, because we were looking at DB2 and how DB2 may have a possibility to serve as a storage layer for Hyperledgers. So that was I would say, first exposures to blockchain technology. It was a fascinating experience, and a lot of smart people around me learned a lot about the Hyperledger technology and the blockchain technology overall. Then I was involved in a lot of different the apps and different chain constructs. recently being involved in the proof of stake chain that is going to mainnet very soon. So very excited about everything. But my main drive with all my involvement of different projects is to bring those decentralized apps to mainstream audience. Because in a lot of cases, we can see we have a hobby group. We do know we have a small circle. We have a hobby group. So we know about those decentralized apps. We know those use cases. We're excited about it. But for majority of the I would say mainstream people, including medias and the other like regular people, I would say, that not familiar with the blockchain at all, they don't really understand what this fuzz is about. They don't understand the potential of decentralized apps. And my drive and my goal always is to bring those decentralized apps and bring those benefits to everyone in the world. That's my goal, and that's why I was involved in MetisDAO project. And let's talk about Ethereum, the good part of it. So when Ethereum was first introduced, I was so excited because in my eyes, it is a distributed computer. Of course, it is not. But when it first introduced with EVM and other things, like small contracts, like, gosh, we have a distributed computer now. In the next slide, I will talk about the shortcomings. But throughout the history of Ethereum, we have the EVM that was a breakthrough. Then we have this ICO thing. It basically means that anyone can create a token, create a project, and get funding with that way. Then afterwards, we can notice that we'll notice that a lot of applications or I would say projects are about financials. So it's more about financial transactions, financial funding, crowdfunding, all of those. The recent DeFi is about that. So that particular direction is really hot, mostly because the shortcomings that I'm going to show today. These are the limitations that I think the current Ethereum 1.0 construct has. Low TPS, I think everyone ever used Ethereum will know. If you're not give a very high gas fee and provide to the miners, you're gonna wait for quite a while to get your transaction done. And then this gas fee is really expensive. I don't know if anyone had experienced beginning of the year when gas price, average gas price is like more than 100 or even 200 walk away. And that was when I just can't do anything. I stopped my application. I can't afford those gas fees anymore. The applications cannot survive on Ethereum unless I'm dealing with all the financial transactions where I can get my costs covered by all the commissions that be involved. And this is probably one of the reasons, in my opinion, that a lot of applications on Ethereum right now is about financial transactions and funding stuff. And the suboptimal user experience, I think anyone been using Ethereum knows. I think to a lot of tech-savvy people, MetaMask is quite a nice experience. But I've tried this with a lot of, I would say, regular Joes who try to use MetaMask, and with Ethereum, they just can't get the hang of it, I would say. It's just a very different experience that they have been get used to. For example, when imagine you log into Facebook, right? You type in your username and password, and they probably have a two-factor authentication, and that's probably it, and you get into Facebook. But for MetaMask, it's just like you don't see your username, you don't really get your password. Your password is somehow saved in MetaMask, and there's so many different network. There's so different accounts you can manage, and it's just not a straightforward, I would say, regular user experience. That is a major limitations for a mainstream adoption for the dApps. There are many projects trying to address that by introducing a layer of centralized management account management. But that's still actual work. Like it's not easy to work around. And people may ask, hey, you're creating a centralized layer in your project. And we get a lot of questions about that. And everyone, I think everyone remember the crypto is a kitten, right? Crypto cattle. I forgot the name now. So when it was first introduced, it was so popular. It was a game, a NFT game. it was so popular where it could basically congested the network. So the network can handle that number of transactions anymore, simply because the throughput is so low. So if we say the purpose of Ethereum is actually to have a real life large scale adoption, and then I don't think it's even possible, because it can't even handle a kind of a silly game, not a silly game, but a kind of a simple game that still a small number of people are playing at the same time. So all these limitations coming, so it basically have a lot of us doubt whether there's indeed a future of Ethereum, especially in this conference. When I say that, I definitely get a lot of eye rolls. And the answer is yes. There are actually a lot of researchers, a lot of colleagues of us trying to research a lot of ways to expand the scalability of Ethereum. And layer 2 is one of them. So there are many flavor of layer 2s. So state channels, Plasma, Rollup, they are all layer 2 constructs, and maybe there'll be more in the future. I'm not going to expand into what the channel is, what the Plasma is, Rollup is, because today's topic is about Rollup. So how about I get, let me move this little thing here so that it doesn't cover everything. So what is Rollup? Rollup means? So Rollup means that we have a lot of transactions happening, and we can actually combine all those transactions into one state root. So we can actually compute a state root using record trace combination to have that state root to be representative of all the states as a result of a batch of transactions. And all we need to do for rollups is to save that state in the mainnet. And that's the only operation they need to do. Because the actual transaction doesn't matter. We just, as long as we can save and verify the state root of all the transactions, then all those transactions are valid. And that's the whole premise of a rollup. Of course, it's a very simplified version of rollup.